what I've been working on is this simple WAV library. And the reason I'm working on this is because I want to get more into programming like audio plugins and stuff like that. And there's really no good way to test that kind of stuff without just sending some audio through them, you know? So that's kind of what I want to do, is just be able to load some WAV files and then use them on signal processing stuff and then save them back out. Maybe play them. I think what I might actually do is just make a simple thing that just plays a file. Like right now, all I'm doing is just taking an argument and then I'm reading the file and then I'll just play it right afterwards. I think that's probably the simplest thing to do for what I need. That way I can have I can hear exactly what's going on right as it happens, which is basically all I need. But I'm still in the process of actually loading the file properly, so I need to have a way to check that, which I think the way I'm going to check that is I'm just going to implement saving the file, and that'll be the easiest thing to do. Which means I probably want to separate this out. And this is very, oops, I guess eventually I'm probably going to take this code base and rewrite it so it's more STB-like, you know, because the way it is right now is it's separated into a header and a source file. But it probably shouldn't be, you know, it should probably be one file, and I should probably not use external type defs for my types and stuff like that. But all that should be pretty easy to change later, I'm hoping, anyways. I guess the first thing here would just be to do okay, then I need some functions. And right now I think I'm just going to not have any parameters in terms of how I write the file back out. I'm just going to write it back out as 32-bit floats. Because there's a few different ways, if you look at the WAV spec, the way it works is you can have, well, the normal way everyone usually does it is uncompressed, which is just in a certain part of the file, there's an audio format selection, which is usually either 1 or 3. 1 meaning that it's just completely uncompressed and it has integer format data, and then 3 means that it's uncompressed floating point data. So I think I'm just going to assume that it's always 3 in terms of writing it, and I can go back and change that later, you know. So that should be pretty simple. Hello there. I have a viewer. I'm gonna have to like alt tab to the Twitch chat every now and then. I'm completely new to this whole streaming thing. So then what I need to do here is I need to look at the spec again and write out everything that needs to be written out. So maybe I should just open up a sample WAV file actually, just to see in hex exactly what's going on here. Hang on a second. So this looks like it's in big endian order, right? So I can just write it out byte at a time, basically. I'm not working on a game exactly. I'm working on, basically, I want to learn some more about like audio plugin programming and stuff like that. So I'm writing a little like tester tool to just import audio files and then transform the signal somehow and then write them back out, or just play them, like something like that. It's pretty simple right now, but I'm just working on a WAV loader. So that's what this code is. So if you look at the WAV file, the first 4 bytes are always RIF because that's sort of the file format, I guess. And then after that, we have the total size of the file, actually, I think. Let's see here. Uh, 36 plus subchunk 2 size. So the rest of the file minus these 4 bytes themselves. So in order to do that, I do actually have to calculate how many samples I have and that kind of stuff. So the first thing I guess I'll do is I'll just write out RIF. What does it just put C, right? Actually, I could probably even do RIF and then, oh, I need the file first. I have a little bit of game and programming experience, but it's all pretty much like unfinished projects. So I'm trying to just sort of scale it back down and do something really small just so I can finish it. So instead of doing like a whole game with all the different systems, I'm just trying to narrow it down to just doing one thing, which I decided to do audio since I love like making music and that kind of stuff. So I think it goes well together to be able to write the plugins that you can make music with. So that's sort of my goal here. So this should just output. I have to actually call this from main, that's right. So I'll read the wave and then I'll just write the wave back out. And then what are my parameters for that? I've got so then I need to calculate okay, so if I look at the spec again, oops, it looks like the entire chunk size is this. So 44 minus 8 would be 36 bytes plus all the data that comes after that. I haven't played Undertale, no. I'm actually not, I haven't had time since entering college really to play games as much as I'd like. So I've sort of been trying to do more programming and music and stuff like that. Let's see, 36. So in order to do this, I actually do need to calculate the size of the data that I have. So the simple wave should be the sample rate. I don't actually have any of this yet, do I? I haven't written this out. So I should do 36 plus wave number of samples. Not wave channel 1 or channel 2 actually. If not wave channel 2, then 1 else 0. So what that does is that just if the channel 2 is a null pointer, then that means it's mono signal. It's a mono signal. So oh, this should be 2 actually. So if it's a mono signal, we multiply the number of samples we have times 1. Otherwise, we multiply them by 2 because we have a stereo signal. So I'm going to log that. And let's see if we get something from that. Actually, I'm going to put let's see what this gives us. Really should, you know, I'm gonna try and bring up Twitch chat on my phone because it'd be nice if I could not have to alt tab so much. Yeah. I don't know much about game design in general. I'm more in the techie side of things, you know. It's sort of where I look. Undertale racing. Okay, let's see. What have I got left? Oh, I need to actually call this function. So let's see what we get from this value. Oh, I need to return. For now, I'm just going to return true. I like to return the arrow codes just because it makes things a little simpler. Okay, that's wrong. That is completely wrong. Oh, you know what it is? It's because I'm not actually populating this number of samples at all. Okay, so I populated the channels, but I never actually populated any of the other properties. Okay, so what else do I need to populate? I need the sample rate. Let's just do that after we parse it. Total samples regardless of whether or not the signal is mono or stereo, or it could be the number of samples that includes both mono and stereo. So if I change this to the, I don't know how to name this. Actually, number of samples, I'll just have to remember that. It refers to the number of samples of any one channel, not both. That works, and then what else do I need? Stereo needs to be, oops. this needs to be. Okay, that is correct. So something else is going on here. Let's try to just wrap this just to make sure. There we go. That looks more right. Because this should be that number divided by, or times 2 plus 36. Plus 36. Yep. Looks like we're good. I'm not really sure how hex works. Hex is pretty interesting, actually. Basically, the way it works is instead of having 10 digits like there are in decimal, you have 16 digits. So it goes, if you look at the way these columns are counting down, it might be a little tiny. I'll do it over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So the way normal decimal works is just 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see if you count the number of digits here, there's 10 digits, right? The way hex works is instead there are 16 whole digits. So you have the first 10 that are the same, and then you have A, B, C, D, E, F. So what that means is you count all the way up through A, B, C, D, E, F, and then you count to 10. So you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10. So in hexadecimal, the letters or the numbers 1, 0 actually means 16 instead of 10. So that's kind of the trick to it. And the reason why it's so useful for programming is because 2 hex digits perfectly represents the amount that an 8-bit number can hold, right? So it's basically 4 bits. The limit of 4 bits, the information that it can hold is also 16, right? So if you have 8 bits, that corresponds to 2 digits of hexadecimal, right? 0 through FF is where it goes. So yeah, it's super useful to know that kind of stuff. But I'm not actually dealing with hex in the code. I'm just dealing with hex when I'm looking at the file, and then you can translate to that to the code, which is kind of the way you usually do it. It looks like I have the right number here, so I can write that next. So since I have the remaining file length, I can write that in a, I need to make sure it's little endian though. Takes the void pointer, the size, the count, and the file. Same as if read, except you're writing instead of reading. Cool. F write. Wait, why do I need a void pointer for that? I guess because you pass it a buffer. So that should correctly write that. And I'm going to run this, and then I'm just going to hex it to see if it actually does what I want. Oh, that should actually be it because I took out all the file stuff. I should just do a print at the very end just to make sure. makes sense that the lower bit is lower, right? I think that's right. I'm just gonna hope that's right. Okay, so now I've written out the first part of the header. What's next? Let's go back to my WAV spec. Format is just the letters WAV. So I can do an fprintf again. Oops. Both the end of that section and the header of the next section, fmt space, subchunk 1 size, 16, always 16. I wonder if I can just do this, void pointer address of 16. I don't know if you could take the address of literal. Let's try it. Is that just 16? Subchunk 1 size, that's actually I32. Let's see if this compiles. Yeah, no, that doesn't work. What's next? Next we have our number of channels, which we can easily write using, okay. Oh, audio format is next actually. Well, that's easy. We know it's always going to be 3. Sent a link, let's see what it is. Yeah, I think music should be explored in terms of its usage in games some more, you know, like there's a lot of games that focus specifically on music, but music in other games that are not specifically about music has not really been explored. There are games like Fez, which I played a little bit of, that have sort of timing based levels that move with the music, and those are some of the coolest levels, you know. To me at least, as someone who's super interested in music, I always enjoy those kinds of games. Where are we at here? Audio format. That's 16 bits, so we are gonna do this is always gonna be 3 because we're only just writing out floats, we're not writing out ints, so we'll take the address of that. Next is number of channels, which is also 2. Actually, I'm just gonna make 2 variables at the top and call them this should be, that way I don't have to duplicate a bunch of variables. Then Then I can do buff 16 equals. Oops. That should be good. I just always want to continuously check this just to make sure everything is going good. Yeah, I've heard really good things about Undertale's music. I've listened to some of the soundtrack too. Yeah, it's certainly really good. I love how it uses such a variety of style. You know, it has 8-bit, it has analog, it has guitars. It's got some nice fusion. Okay. We've got our 3, we've got our 2, that should look identical, right? 3, 2, yep. Next is sample rate, which should just be whatever the sample rate initially was. Next is the byte align. Oh, that's right. I didn't actually have to deal with any of these when I was reading the file, but now I have to write them back out. So this is the sample rate times the number of channels times the bits per sample. So bits per sample is going to be constant because we know that we're only ever writing out floats, right? So this is always going to be 32, right? Oh, this is always going to be 4. So 4 times number of channels times sample rate. Since we set buff 32 to sample rate, we can do 4 times buff 32 times. Yep. Technically, I don't need to cast here for any of these times, but if I wanted to compile this as C++, it would not work. Good music. Can't say no to good music. Oh, I've heard this one, yeah. I think I actually used to have this soundtrack on in the background when I was programming. I like to go through a lot of different types of music. I'm gonna turn off the other one here. Hope I don't get copyright stricken for any of this. Okay, next is number of channels, block align. So this should just be this divided by the sample rate. Okay. Right. Let me just double check all the sizes of these because block align is 2. Okay. That's 4, that's 4. This should be 2. That should be good on that front. Yeah, I like this music a lot. bits per sample. Oh, this is constant as well because we know our bits per sample. I'm just checking. Yeah, bits per sample should always be 32. And this is 2 bytes long, so we need to write it as 16. Okay. That looks like it is. Okay, now we need to do the actual data subchunk, and then we just need to write down our interleaved audio samples, and we should be good to go. So I'm just going to consider writing data in subchunk 2 size as part of the header, and then everything else will go in the audio. So this function only needs to write 2 more things, which both need to be 4. Okay, so this needs to be data first, so let's fprintf. And let's subchunk 2 size, the number of samples times the number of channels times the bits per sample divided by 8. Okay. For this again, I can do left32 equals I should actually just change this to oh, I already do have number of oh, I need the number of channels. Oh, thanks for the follow, I appreciate that. This is my first ever stream actually, so I'm brand new to this. I just thought, why not, you know, share some programming. Okay, that's fine. Now I don't need to have this weirdness here. Wait, what's going on here? Okay, we have one more instance of stir that can be changed to num channels. Oh, of course, yeah. That should be the entire header written out, I believe. Let's compare these two. Okay, this is some extra sections that we don't care about here. But anything after this byte here is considered, so data in my file should be where fact is in this file, which it looks like it is. So I think I'm good to go. I can double check that here. Yep. And then I've got the size of data right after it, which looks like it's the same, which it also should be, right? Because the number of samples does not change, right? 0441C09. Yep. So I don't actually have to, I guess I should be checking the result of all these f writes, but for now I'm not going to worry about that. Just return true always. Now let's write the actual data. make a new function for this just to make it a little neater. So now the file should be set to seek, or should be seeked at the right position, right? Because the last 4 we wrote were at the number of samples in this subchunk 2 size. So right after that comes data. So now I should literally just start being able to write bits and bytes to the file. So the thing I need to figure out now is how do I interleave it, right? Because if the number of channels is 2, that should interleave it. So what I actually have to do is in my swrite file, I don't want to branch instruction every loop though. So I think the way I might do it is, oops, I messed this up. I think there's a simpler way of doing this, which would be, because if number of channels is 2, then the way we can index into the array is by doing array channels times 2 plus channels plus 1. I think that'll do it, because what this will do is if num channels, because we want to iterate, if num channels is 2, we want to iterate twice the length we would. Num channels times because num channels times I, if num channels is 1, will just be I, which will do what we want. Cool, I'm back. We're almost there, we're almost there. So close I can feel it. I'm just gonna do the if statement. It's a little bit cheesy, but it should work fine. I'm gonna need the same for loop in both. And then in this one, all I need to do is just do array I. But in this case, I'm actually doing an f array, right? Channel 1. Oh, just I actually. And then I do an f array with sample. Sample 2 times size of. Actually, I want to do. Still getting used to those type defs. Then one of those, and then file. And then in this case, I would not do that. I would instead just do a float. And then do an f array with that instead. And that should be that. Theoretically, this should actually write the entire file. Oh yeah, that's right. And this one I need to actually take the address of it. I'll just return true here. Okay, let's see if this file plays. That's the real question. The real test is whether or not this file plays. Nope, it does not play. Which means something somewhere went wrong. So now the question is to find out what went wrong. Which I might leave for later because I have some stuff to do right now. So I think I'll cut off the stream here. We're very close. I'm very close. I can feel it. The entire file should be pretty much written at this point, right? If I refresh this, do I actually get... I don't actually get any data. Am I calling this? I'm calling this, right? Right audio. I'm iterating the right amount, right? Wave number. Oh, no, this should be number of channels equals 2. Yeah, that makes more sense. Okay, let's see if the file looks long enough to be correct. Yeah, okay, the file is super long now. Starts with a bunch of zeros, which is what I expect because the file that I inputted starts with a bunch of zeros. See here? So they're both similar in that respect. Let's try running it. Okay, that works. That is so cool. I successfully imported a wave and then outported it, which is like, you can't really tell that it's happening, but I know it's happening. And that's all that really matters, right? I think I'm successful now. So the next step would be either I can actually add compression to this so that I can import and export compressed waves, or I could just rewrite this in STB style and then just let it go there and actually start doing some like plugin style stuff. But I think I'm going to leave that for the next stream if and when I do stream again, which I think I will. It's kind of fun to talk while you program. It helps you think things through, and it's nice to chat with people. So, but I think that's going to be it for now. So thanks for watching, anyone who actually bothered watching. It's kind of pointless right now, but I hope I can get something out of this later, and I hope you got something out of watching this. Thanks, and bye.